Hey guys, welcome back to the shop. We have a shaft here that we're going to be doing a flame spray repair on, and this belongs to a longtime viewer and a friend of mine, Kevin Pangle, and it's for a belt sander that he's working on. It goes to, I believe it's a Rockwell belt sander. And so Kevin is the guy who actually found my G&E shaper and contacted me about it, helped me make a deal with the owner, and he also helped kind of organize the group of folks that came together to help get it dug out of there and get it out of that machine and get it loaded up for me. So, big thanks to Kevin and everybody that helped out with that shaper project. I think that was back in 2017 is when that was. It's been a little while now. But anyway, Kevin had contacted me and said that he had this shaft out of this belt sander that's got a worn bearing journal on it, and asked if I could fix that up for him. And I told him, absolutely, send it on down here and we'll get it fixed up. And Kevin was kind enough to donate all of his time on getting that shaper out, just like the other fellows were. So whenever he asked me about doing this job for him, I told him just send it down here and I'll donate my time to get this done for him and get it back up there to him. So that's what we're going to do, try to get him fixed up. So we're going to be using my Eutectic flame spray equipment to do this. And for anybody that might be watching this video and hasn't seen any of the spray welding that I've done, I've got a playlist on the channel that goes back probably 11 years now that has several jobs that I've done on flame spray buildup work. So my intention was not to go into a heavily detailed video explaining every step of the process. I just want to get this guy fixed and get it back in the mail to Kevin because I do have a lot of other things going on, but I wanted to show this because I like sharing all the projects around here. But please check out the playlist. I've got a lot of videos that go into great detail on everything that it requires to do the flame spray. This is the metal powder that I always use, the 21022 from Eutectic. It works really good for bearing journals or oil seal journals or any kind of journal that might have some wear on there like that, okay? So we'll get it in the lathe. I'm going to mask it to protect these threads here and to keep the flame spray from building up on these other areas. We'll have to undercut it. We'll build it up, let it cool, and then simply turn it back to size. This is a 6204 bearing. So that should be a 20 millimeter bearing journal that we're going to be fixing there. Yep, 787. So we'll go to the Victor lathe and let's get this shaft fixed. It's running nice and true in the 6-jaw here. We're using our masking compound to get it masked. Solution 103 from Eutectic. And this will all just polish off whenever we're done with the job here. This is a little trick that I use to help that masking compound dry very quickly without putting a ton of heat into the part. All right, now that masking compound is dry, we can come in here and do our undercut. Actually, let me speed this up a little bit. It's kind of a small diameter we're working with. And since this has already got quite a bit of wear on it, I'm only going to clean it up. Get to where it just cleans up. And I am using a threading tool. I was taking 5/1000ths hoping it would clean it up, but it's going to take a little bit more than that. This one has been running a long time with a worn bearing journal. Still not enough. that wear. Almost got it there. Now, if you might be asking about just making a new shaft, that's certainly another option there, and that's one that I had joked around with Kevin. I was like, man, why don't you just make you one? And he's been in the middle of setting up his new shop and getting his machines moved out to the new shop, but they're not wired up yet, so he can't make a new one right now. So we're going to get it flame sprayed. I think that's going to work right there. Yep. So next up, we'll cut a real fine thread pitch across there. All right, that is a 28 pitch thread. I went 15 thousandths deep. All right, let me make sure everything's regulated good here on my oxygen and fuel. And get ready for the pop, okay? Yep. We got Abby helping us with some camera work here. Oh, come on. I'm getting hung up on the mill here. Oxygen. Preheat. Bond coat. Build-up coat. There we go. See, it don't take long at all for them small journals anyway. I know I do, because you tell me every time. All right, there's our build up. Always go about 50 thousandths over your finish diameter. So that right there, the smallest diameter is 843. We're going to finish at 787 or 20 millimeter. So that'll be good. We'll just let this cool. I'll put a fan on it, let it cool. When it's cool, we'll turn it.
I should have gotten that with this.
Got it with that though. It's okay. They've seen it before. Most of them anyway.
You're going to fire me.
I'm not going to fire you.
Next time.
I need all the help I can get. Put it over. Oh, do you want to get a picture first? Now I'm posing for photos.
You look cute.
Watch your nice Yingling sweatshirt there going to get oil on it.
I didn't even get close to touching that.
I saw you touching that lathe right there. There's oil on it. I was just letting you know. It might,
All right,
you
thanks.
get a spot on it.
I think I'm okay.
Will you do me another favor?
Yeah.
Will you grab that plastic fan down there and just set it right up here? Make sure that it's just plugged in to the back of the lathe. Yep, right there is fine. That'll work. Yep. Just like that. Put it in low gear. That's it. Okay, our shaft is nice and cooled down, cold to the touch. We've got a brazed on carbide tool. That's one of my Micro 100 tools. They do a really good job turning this build up here. First thing we do is just knock down all of the excess, you know, the extra and the outside of the buildup area. Usually all you got to do is just touch it, and that's part of that masking compound that we put on there. It helps prevent it from actually sticking and bonding to the base metal. All right, now that we got a straight cut there, I'll get a measurement on it just to kind of see about where we're at. So about 850, about where we are. And by the way, I've got there's our bearing fit for a 6204 for the shaft fit anyway, your maximum and minimum. So that's the tolerance that we're going to be shooting for whenever we measure it. So we start with light cuts. About 20 thou is the max that you want to take across this stuff. Let me see, I got to get it out of threading. Here we go. Had it in the wrong selection there. I usually feed it about 5 thousandths per revolution. As long as you have a good tip, carbide tip, it'll leave a good finish on there too. All right, I'm going to go ahead and get a measurement using our micrometer now. All right, 825, 35, 67, so we're at 837. As we get down close to those threads, it should start peeling right on off there. There it is, peeling some of that buildup off the threads. Get another measurement. I do this with my fingers because I want to make sure that there's no dust left on it from the last turn. So we're at 812. See it peeling it off the thread. Okay, we're at 803, so we're getting close. We got about 15 thou to come off of it. This is a 10 thousandths pass, and then we should have maybe one more finish pass. $793. So that would be 1, 2, 3, 4, 5. We got about 5 thousandths. All right. I like to leave the buildup approximately 1 thousandths oversized and finish it with emery paper. It makes it look a lot nicer, and it polishes off those the tool marks on the top and helps bring it down to a more uniform size. I think I'm just going to take a couple of thou and see what it does here, and then come back and we'll take one more finish pass. Kicked it up to 600 RPM. All right. One more measurement here. Got about 2.5 thou. I'm just going to dial in 2, and we're going to leave it there. I am going to back off here just because I know it's not going to drag and leave a tool mark, but just in case I need to come in here with a tool again, I can. So we finished it at 789. So that's going to give us about 1.2 thousandths to polish it down. All right, I think what I need to do is come in and where the buildup meets the thread, I need to clean that up just a little bit. So let's come in here with our tool. I'm going to bring it in until I just see it touching those threads. Right there. All right, it looks good. I think from there all we got left to do is to polish it. I like to come in with a wire brush and try to get the rest of that masking off there, and it gets down in those threads. Cleaned up nicely right there. So we'll go ahead and hit the buildup lightly with our emery. It won't take much to bring it down. Yep. This is some 220 I'm using, by the way. All right, 788 and 1/10 right there. So we're getting real close. It's got a slight amount of warmth to it. I don't think it's going to affect it. All right, so we've got 2/10 left to bring it down to size. I'm just going to let it cool for a bit. I tell you what, let me use one of these dirtier pieces. I want to get this cleaned up right here. Just get the masking off of it is all. That corner, clean it up. Clean this up right here. Just make it look nice. I'll hit those threads again. All right, I'm just gonna give this a few minutes, sip on some coffee, let that cool down a little bit more. It's not hot at all, it's just got a slight warmth to it. And then we'll just do a final polish to bring it down, whatever it needs to get it down to that tolerance level. Okay, it's cooled down. I did a little bit more cleanup on it, but I think we have it right where it needs to be, right where I want to leave it anyway. So we'll do another measurement on here, 787 and 5/10. Okay, so that worked out good. That is on the bottom end of our tolerance that we'd like to be in for that bearing fit, so that'll work out really good. All right, this guy is going to be done. Let's go ahead and take it out. I think what I'll do while we got it in the lathe here, see I cleaned up that end just lightly. I think what we'll do is go ahead and give this other end just a light cleanup. Not trying to reduce the diameter, just make it look a little more pretty is all. I've got a wider piece of 220 right here. Just something like that. Didn't really take much. Left-handed thread. Just give that a little polish with the Scotch-Brite. Just pretty it up a little bit. Okay. Well, this guy is DUN done. Well, this is going to finish up the shaft for Kevin. I think he's going to be happy with that repair, and that'll get him back in business. As I said, it was for his Rockwell belt sander. I believe it's a machine that he's been working on, getting fixed up and get ready to put it in the service. And this is one of the issues that he found was the bad bearing journal right there. So he'll be glad to get that back. So this could easily be a shaft that you can make on the lathe instead of doing the flame spray repair like that. If you didn't have a flame spray repair and didn't feel like welding this up, building a new one would be the next best option there. It's relatively simple lathe work. Let's see, they used a piece of 1 1/8" diameter shaft stock. I don't know if that's cold rolled or what grade it is, but simple enough turning and threading on both ends, and then milling a keyway. Simple enough. But doing the shaft repair like that with the metallizing, with the flame spray repair is just an excellent way to fix a part like this quickly, efficiently. You're using the original material there, the original part, not having to replace it. So for me, it's just a valuable option that I have in my shop to be able to help get parts repaired quickly and back in the service. So we're going to get this guy boxed up. Kevin supplied a nice tube there with some foam inserts to protect it. We'll get it back in there and get it shipped out back up to him in Pennsylvania. All right, guys, I hope you enjoyed watching this flame spray repair, and we'll see you on the next project.